Continuing on with our week 2 vibrations class. This is video 4. And we're continuing on with our examples in our book. Is it a long example? No. It's very similar to some of the other examples here. It's a rigid body, right? So just a little bit of a variation. There's a note in here where I wrote that assume J about O is equal to known. That we know it, right? So this shows a uniform bar that's pivoted about O with springs of equal stiffness K on both sides at each end. The bar is horizontal in the equilibrium position with spring forces P1 and P2. Right, so those spring forces, they must be the static spring forces. Determine the equation of motion and its natural frequency. Okay. So there's a couple of issues I had when working through this on my own. One is I didn't like the pluses and minuses that they were using in there. I thought it might be confusing, but I will try to explain that they tend to not, well, no, all the pluses and minuses do matter, but when you get to the equation of motion, it doesn't necessarily have to be a plus sign as we normally see. I mean, we're going to look for, in this you can see that rotational is a behavior. So our goal is to find something that looks like this right there. This plus sign, I have seen other people, other professors, I'm not sure I've seen other books, but maybe I have seen other books where that it's okay if that's a minus sign, because then it just turns into the solution for, you know, the big idea solution is that it's a cosine that ends up being onto the place, or kind of along those lines right there. We could fix it with a phase. I've seen it get mixed up by the way that the derivation was set up. So we're not gonna cry little crocodile tears if we get the wrong thing. Conceptually, it is the same. So we'll do an FBD and an IBD. And actually, before we did that, I should have put in here so we can get some things to cancel out. Only because they decided to go ahead and in the setup for the problem, you know, concern about the initial conditions and then go back and change it. So this is going to be just an FBD of the thing over to the side where we have the statics, and maybe I'll start using things. All right. So the question is, when it's in this equilibrium position, are the P1s that they're describing, are they going up or are they going down? I decided that they were going down because there's going to be in tension. So I said P1 and P2. I'll put the reaction right here, which is going to be RY. And then we also have the, you know, really the thing that's working right here is the mg. I want mg. Okay. So we have the mass of this thing, mg. Anything else? No. So some of the moments about, what are we calling that? O, I guess, yeah, well, it is O. O is equal to 0. Boom. And I said, okay, P1 times A minus mg times C, right, because there's the C, and then minus P2 times B is equal to 0. And we'll just save that for later, because our whole purpose in doing it is to get rid of it over here when we're doing the FBD and IBD. It's also the question, should we make this thing go upwards or downwards? Well, they're showing it the angle being downwards right here, so that's where I decided to go with it. Make them equal to each other and then start adding stuff in there. All right, so now I'm going to put in forces, but now we're going to have, I decided to call this FS1 for spring, and that's just going to be FS2, because if it's going downwards, this is like going to be some compression coming up into there. The sign's going to it's aggravating. Don't worry about it. All right, so here is the RY that's coming into the play, and here you go. Here's the MG, and that's the only thing we have going for us. Other aspects. I'll put the theta in there, and maybe I'll put a theta into here too. I don't think it matters. It doesn't matter. And then for him, I don't know. I like counterclockwise. Which direction is this? Well, is it on its way down, or is it on its way back up? And is it accelerating as it's going on its way back up? I don't know. I got hooked into calling it J. I'd rather call it I. For the mass moment of inertia, but what are you gonna do? And there you go. So if you go to okay, so a little bit another to the thing on the side. I guess I'll do it in red. FS1 is going to be equal to A theta K plus P1. FS2 is going to be B theta K minus P2. All right, so things to know about that. This is a small angle approximation. So instead of using sine, we're using just theta by itself. So it's the amount of this displacement, and this displacement is what we were looking at right there, times this spring constant, right? Plus so that's the force because it moved, and then over the P1 and the P2 was the initial force placed right in there. It really seems to me like this is almost like an unnecessary step, but what do you do? I haven't used orange much, so we're going to use orange. So let's use the sum of the moments about O is equal to, what did I say? J. I'll just keep it this way. All right, okay. Counterclockwise is positive, and then I wrote that F S1 times A. Okay, so I'm just trying to separate that out a little bit more. FS1 times A minus mg times c, because the FS1 is going counterclockwise, so it's positive. Mg is going clockwise, so it's negative, but we remember it's got to be a moment, so we can multiply that in the distance. And then plus Fs2 times b, and that's counterclockwise, so it's positive. So that's all the force causing, moment causing forces on the left hand side, and then JO theta double dot. And now we can replace some of the stuff that we had over here. So we go, I'm going to go to distributed. I'm going to A squared theta K, right? Because the A times this FS1 is at the top, plus P1A minus MGC, and then plus B squared theta K minus P2B equals JO theta double dot. Now we look for, running out of colors here. I don't use purple for much. Okay. Notably, let's go back here and look for that guy, and we'll see, oh wait, that guy, this, that, and this, and that, this is all equal to 0. Boom. So we can rewrite the thing out. We I guess I just skipped a step here, but you can see for yourself. The sign over here is going to be negative, so that's what really bothered me, is that this stuff over here on the left is jumping over the equal sign, so it's going to be negative here. So you're going to get A squared plus B squared times K. I also did a little jumping around there, divided by JO theta equals 0. But I think we could probably make out all right if we decided that it was accelerating in the opposite direction from what we had right here. We know that it's going to be, that standard thing. There's nothing special about that minus sign. And I think I one time had my head organized enough to explain what scenario you need to do to address that. And I think I've gone to the point where I'm just going to go hit the accept button. It's a little button right here. There you go. Actually, I was thinking about getting one from Amazon. And you hit the accept button. I believe. I don't want to do that too often. I think that there's a certain amount of skepticism, healthy skepticism, that we should all maintain. But at other times, I think there's just, you have to take it like you have a little faith in this world. That like, okay, that minus sign, it's making me nervous. I don't like it. Explain that to me. I'm going to let it go. Just let it go. Just like in Frozen, isn't there a song like that? I've never heard that song. I know of it. I know people complain about it. But I've never heard it. And I don't want to. I think I'm okay. Ignorance is totally cut. Sometimes, in some respects, ignorance is blissful. Blissful ignorance. I'm going to make another video.